Good morning, everybody. Thank you very much for this up. We have Good morning, everybody. Thank you very much for this opportunity to be here in the 30th International Colloquium of Gerpisa 2022. My name is Nelson Bento. I will be presenting the how-to tools of Quality 4.0, support the principles of TQC, TQM, a theoretical and practical perspective. We have a content related to this issue for introduction, concepts and principles of TQC, TQM, Industry 4.0, Quality 4.0, research methodology, analysis and discussion of results and conclusion. Prior is very important, an introduction of the quality function that has been a decisive influence on the delivery of excellent products and services to the customers. In the 20th century, quality management systems were developed and established in the periods of Industry 2.0 and 3.0, bringing undeniable benefits to quality as TQC, Total Quality Control, originating in Japan, and Total Quality Management, originating in the United States of America, both with the same content. Industry 4.0 applied to the quality systems is so-called Quality 4.0. And in this sense, the objective of this research is to verify how the Quality 4.0 tools can support the TQC, TQM principles. When we start talking about TQC, TQM and the quality, they can be defined as a systemic approach to the management of a company based on management by processes and continuous improvement of business performance by all human resources in order to satisfy the expectations of customers and other interested parties. So then, TQC/TQM is a very pervasive management approach aimed at improving company routines, relationships, and results to ensure stakeholder satisfaction and value creation. When we talk about the principles of TQC/TQM, we have the principles blocks as customer orientation, related to customer focus, customer satisfaction, fidelization, value creation to the customer. We have also orientation to the system, management by processes, and teamwork. In the same way, we have the orientation to people, people satisfaction, empowerment, leadership and commitment of high administration, continuous improvement, and of the high administration top management. As well as we have orientation to learning, continuous improvement, and leadership. When we go to Industry 4.0, the term Industry 4.0 came as an introduction in the year of 2011 by the Communication Promoters Group of Industry Science and Research Alliance in Germany to describe the widespread integration of information communication technology in industrial production. The main technologies or the pillars of technological issues of Industry 4.0, we have the cybersecurity, cloud computing, mobile technologies, machine-to-machine, 3D printing, advanced robotics, big data analytics, Internet of Things, RFID technologies, cognitive computing. So then, for Quality 4.0, as a historical evolution of the quality, we have to consider First of all, the term Quality 4.0 was structured by Dan Jacob, Research Director and Principal Analyst of L&S Research. And Quality 4.0 is closely aligned in quality management with Industry 4.0 to enable organizational efficiencies, performance, innovation, and improved business models. Technologies such as CPS, cyber physical systems, Internet of Things, cloud computing have been used to meet requirements in terms of design quality, compliance quality, and performance quality. When we see the periods of the quality evolution, we see the 1.0 based on production volume. Quality is assured through measurement and inspection. 2.0 with others of standards to reflect the minimum level of quality acceptance. Label performance is used to measure productivity. In the 3.0, so we have a business imperative as a quality function. We have the customer satisfaction, a continuous and applied improvement in the standardization of activities as ISO 9001. In the Quality 4.0, we have the digitization being used to optimize signal feedback and process tuning and adaptive learning supports self-induced system corrections. Quality shifted the focus from control orientation of process operators to process designers. And machines learn how to self-regulate and manage their own productivity and quality. Human performance is essential. When we start thinking about quality as a quality 4.0 level, if we start tuning this quality for the maximum, supporting total quality management, so then we can say that TQM is supported and empowered by quality 4.0. The methodology utilized by the research, it was that in this article, it was developed a case study with a questionnaire to assess the relationship between the TQC, TQM principles and how these are supported by the essential elements of Quality 4.0 in order to identify the degree to which these tools act in the management system. Here we have the approach of the questionnaire and the main topics related to Quality 4.0 and the overall impact on the principles. The questions are related to the quality policy for Quality 4.0, traditional quality and Quality 4.0 transition, development and adoption of technologies from Industry 4.0 to quality, how to handle big data technology, improvement of a project quality, product and service quality with respect to compliance in Quality 4.0, improvement in quality control and performance, the use of a prescriptive analytical algorithms, vertical, horizontal, end-to-end integration through Quality 4.0, strategic advantages, leadership impacts, training related to Quality 4.0, and the culture changing from human focus with adoption of disruptive technologies, and how top management is enabled to implement the Quality 4.0 in the company. We can see in the relationship or correlation among all the information we've received and the TQC TQM principles that impact strongly all over the organization. We have still the answers of the questionnaire, and here we have just an overview of what happened, and especially we can identify that quality policy for 4.0 level is very important. Transition between traditional and 4.0, adoption of technologies, big data technology, project quality impacts, impact over product and service quality, quality control and performance, prescriptive analytic algorithms, vertical and horizontal end-to-end impact. Are very strong today, but impacting all over the organization. Considering the analysis of those information, we have that big data implementation was evidenced, but is still in the early stages. Big data analysis comes from the headquarters and is spread all over the world. Industry 4.0 technologies for quality 4.0 monitoring for implementation. There are expectations that quality 4.0 will bring very positive results, and program of implementation expected to, to be accomplished as soon as possible, but at prior to the markets of the United States and Europe. And the main efforts of training are related to big data analysis. When we consider the information of technologies related to the principles of TQC, TQM, and considering the main technologies of Industry 4.0, artificial intelligence, big data, blockchain, deep learning, enabling technologies, machine learning, and data science, we can see a huge impact all over the organization based on the principles of a TQC, TQM. At the end, and going to the conclusion, we can see that and verify that Toyota in Brazil maintains the principles that govern these management systems. The elements for the implementation of a Quality 4.0 and the company is highly dependent on the strategic decisions of the headquarters and is focused on Europe and the United States. It is evident that technological advances originating in Industry 4.0 are bringing leverage to the implementation of a Quality 4.0. And this effort of implementation of technologies for quality supports the principles of TQC, TQM, and leverage the excellence on quality overall organization. I would like to thank you very much for this opportunity.